Welcome to Science 9 class, where science becomes easy, exciting, and interesting. So sit back, relax, and be ready with your modules, paper, and pen.
Let's play Who Am I? Can you guess what element it is by looking at the atomic number only? Let's start. Let's check your answers. So 9 is for fluorine, 55 is for cesium, silicon has atomic number 14, and 88 is for radium. Very good! You perfectly guessed the different elements. It's a good sign that you are now familiar with the features of the periodic table. Can you count me in? How can you measure rice, nails, or salt? When you buy in the market, can you buy it by piece? Of course not. Why? Correct, because the particles are so small. So, we usually measure it by getting the mass. We use grams or kilogram, right? So today, we are going to talk about the mole concept. It includes the molar mass, formula mass, molecular mass, and Avogadro's number. Let's have a word search activity. Can you find the different words given? Let's start. Molar mass, molecules, ions, gas, atoms, mole, and particles. Wow, you get it right, learners! Please remember those words as we go on with our lesson. At the end of this video lesson, you are expected to use the mole concept to express mass of a substances. Specifically, you need to explain mole. You will calculate the mass of a substance. You will describe the relationship between the mole and Avogadro's number, and solve for the number of atoms, molecules, moles using the dimensional analysis. Did you know that matter is made up of particles? Particles may be atoms, molecules, or ions. The amount of particles may be expressed in mole. Mole, whose mass is equal to grams per mole and can be expressed in Avogadro's number. So no matter how big or small you are in this vast world, you can bring impact to society in a way that will be pleasing to the Lord. Just always do what is right. Now, how can we know the mass of the element? So for example, the element of carbon, so the symbol is C, the atomic mass is 12, so that is the molar mass also, which is 12 grams per mole. As you observe, you will simply look at your periodic table and you will get the atomic mass of each element. How about the molar mass of the compound? So for example, the compound is carbon dioxide. The chemical formula for it is CO2. So the first step is to determine the number of atoms of each element. So 1 for carbon and 2 for oxygen. Then, by looking at your periodic table, you can get the atomic mass of each element. So the atomic mass of carbon is 12, oxygen is 16. Multiply it with the number of atoms. So 12 times 1 is equal to 12 grams per mole. 16 times 2 is equal to 32. Then add it all. So you will get 44 grams per mole. That is now the molar mass of carbon dioxide. Same procedure with acetone. So you will get 58 grams per mole for acetone. Now it's your turn to get the molar mass of the following compounds. Number 1, potassium manganate. Number 2, lithium chloride. Number 3, sulfuric acid. Are you done? Let's check your answer. 158 grams per mole for potassium manganate. If you get 42 grams per mole for lithium chloride, you are correct. And 98 grams per mole for sulfuric acid. So molar mass is the mass of 1 mole of a substance, while atomic mass is the mass of one individual unit of a substance. How to get the number of moles? So first step, you have to know the given mass of element or compound. Second step, compute the molar mass of element or compound. Then, divide the mass by its molar mass, or simply, number of mole is equal to mass divided by molar mass. Let's have an example. Compute the number of mole of 0.89 grams of calcium. So the given are, mass of calcium is equal to 0.89 grams. The atomic mass from your periodic table of calcium is 40 grams per mole. The required is the number of mole. For the formula, number of mole is equal to mass divided by the atomic mass for an element. So for the solution, 0.89 grams divided by 40 grams per mole. Cancel the grams so that you left the unit mole. So you will have an answer of 0.22 mole. What about if the given is a compound? So compute the number of mole of 1.25 grams of carbon dioxide. So the given mass is 1.25 grams. Get the molar mass of carbon dioxide. So, carbon has 1 atom times 12, the atomic mass, so equals to 12 grams per mole. Oxygen has 2 atoms, multiplied to atomic mass, which is 16, so you will get 32 grams per mole. Then add it all. The molar mass of carbon dioxide is 44 grams per mole. The required is the number of mole of carbon dioxide. So the formula is the same. Mass divided by molar mass. So 1.25 grams divided by 44 grams per mole. Cancel the grams. Then you will get 0.28 mole. what if the problem is, how many grams are there in 2.43 moles of H2O or water? So the given is the mole of water, which is 2.43 mole. So you will get again the molar mass of water, which is equal to 18 grams per mole. What is required is the mass of water. So the formula for mole is mass divided by the molar mass. Just derive the formula using cross multiplication. So mass times 1 is equal to mass. Then the number of mole times molar mass, so N times molar mass. So you will have a formula of mass is equal to N or the mole times molar mass. Substitute the formula with the given. So 2.43 mole times 18 grams per mole. Cancel the mole and you will get a mass of 43.74 grams. Now it's your turn, learner. Try to compute the moles of 2.20 grams lithium, 4.53 grams of methane, and how many grams are there in 4.62 moles of sodium chloride. So let's check your answer. 0.31 mole for 2.20 grams lithium. For number 2, the correct answer is 0.28 mole. And for number 3, you will get 267.96 grams. Did you get it, learners? Very good! Now remember this. 1 mole of any substance contains a number of particles which is equal to 6.02 times 10 raised to 23 atoms or molecules, and that is the Avogadro's number, which has a symbol of capital N. 1 mole of any substance is equal to 6.02 times 10 raised to 23 particles. So for example, the 1 mole of carbon dioxide is equal to 6.02 times 10 raised to 23 molecules of carbon dioxide. Now, who is Amadeo Avogadros? Let me give you some important details about Avogadro's life. So he lives in 1776 to 1856. He was born in Turin, Italy on August 9, 1776. His family background was aristocratic. Mathematics and physics attracted his logical mind. Avogadro was a lawyer who became interested in mathematics and physics, and in 1820, he became the first professor of physics in Italy. Avogadro is most famous for his hypothesis that equal volumes of different gases at the same temperature and pressure contain the same number of particles. French physicist Jean-Baptiste Perrin used the term Avogadro's number for the first time while explaining Brownian movement. The value of Avogadro's number was obtained by dividing the charge of a mole of electrons by the charge of a single electron, which is equal to 6.02 times 10 raised to 23 particles per mole. How to get the number of particles? So first step, know the atomic mass. If the given is an element, if compound, compute the molar mass. Second step, compute the number of moles. And lastly, multiply the number of moles and Avogadro's number. Or simply, number of particles is equal to a small letter n, which is the number of mole, times capital N, which is the Avogadro's number. For example, how many atoms are there in 6 moles of beryllium? So given the mole of beryllium is 6 mole, the number of particles is 6.02 times 10 raised to 23 atoms per mole. Required is the number of atoms of beryllium. So formula, number of atoms is equal to mole times the number of particle, or Avogadro's number. So for the solution, 6 mole times 6.02 times 10 raised to 23 atoms per mole. Cancel the mole. So you will get 3.61 times 10 raised to 24 atoms. So that is the number of atoms in 6 moles of beryllium. What about if the given is a compound? So how many molecules are there in 8 moles of calcium hydroxide? So given, the number of mole is 8 mole. The number of particles is 6.02 times 10 raised to 23 atoms per mole. The required is the number of molecules. So same formula. So 8 mole times 6.02 times 10 raised to 23 molecules. Cancel the mole and you will get 4.82 times 10 raised to 24. Now what if the given is in grams? How many molecules are there in 32 grams of hydrogen sulfide? So the given are mass of hydrogen sulfide, which is 32 grams. You have to get the molar mass of H2S. So you will get 34 grams per mole. The required is the number of molecules of hydrogen sulfide. So the formula is the number of molecules equal mass divided by molar mass times the Avogadro's number. So for the solution, first is to get the number of mole. So 32 grams divided by 34 grams per mole. Cancel the grams, so we'll get 0.73 mole. To get the number of molecules, 0.73 moles times 6.02 times 10 raised to 23 molecules. Cancel the mole and you will get 4.82 times 10 raised to 24 molecules. Now it's your turn, learners. Try to compute the number of particles of the following. Number 1, 16 moles of magnesium. Number 2, 1.90 moles of glucose or C12H22O11. Number 3, 23 grams of magnesium oxide. answers are correct. To check if you understand our lesson, try to complete the table. So you will get the number of moles and the number of particles of iron, sulfur, aluminum, and sugar. And here are the correct answers. Did you get it right? Very good. Now let's check what you know. Answer the given questions. How do you compute for the number of moles? How is the number of particles determined in a mole of a substance? What is the importance of Avogadro's number in determining the number of particles? What is the relationship between Avogadro's number and 1 mole? How do you find the number of particles given the mass of the sample? And why mole concept is important in daily life? And here are the answers. So you have to divide the given mass of the substance by its molar mass. Multiply the number of moles to Avogadro's number. It is one of the fundamental constants of chemistry that permits and compares the different atoms or molecules of the substance. 1 mole of a substance is equal to 6.02 times 10 raised to 23 particles. Get the average atomic mass of each element. Add the results and get the molar mass to multiply it by Avogadro's number. Applying the mole concept can be useful quantitative tool in daily life. Understanding the concept gives you an idea of how many molecules of medicines are introduced in our bodies. Did you answer correctly all the given questions? If yes, congratulations because you really understand our lesson for today. Now, let's have a short quiz. Just write the letter of your choice on your paper. Are you ready? Let's begin. Number 1. How many particles are equal to 1 mole? And the correct answer is B. Number 2. How can be the knowledge about mole be useful for environmentalists? And the correct answer is D. Number 3. How many moles are contained in 36 grams of CH4? And the correct answer is D. Which of the following statements is not true about mole? And the answer is D. Number 5. Which of the following unit is used in expressing the amount of substance in terms of particles? And the correct answer is C. Did you get a perfect score, learners? Wow, you are all amazing! For your additional activity, you can choose what you want to do. First, you can compute. Number 1, paraffin is a wax used in candle making. During combustion, a 20 grams candle produces 1.42 moles of carbon dioxide. How many molecules of carbon dioxide are released in the atmosphere using the candle? Number 2, during exercise, lactic acid forms in the muscles, causing muscle cramps. If 5.0 grams of lactic acid is concentrated in your leg muscles, how many moles of lactic acid is causing you pain? Or you can create a poem about mole concept. Or design a card game about mole concept using the given rubrics.
Thank you for your time, learners. See you on our next lesson. Stay safe and be healthy. Bye!